Hello and welcome to another lecture in Administration of Operating Systems course. Today I will be talking about some introduction to administration topics. So we have been talking up to now mostly about how to use Linux system, especially the command line interface. Today we will look at it from a slightly larger perspective, so what to do if you are responsible for a system that other people are using as well. So if you think about what are the typical tasks of an administrator, so the first and most obvious one is of course the installation and configuration of the operating system. So you have to start somewhere. Before you have a working system, you are not really an administrator of it. But to prepare the system is definitely one of the tasks that you may have to do at some point. After you have configured it once, you are not done. You still need to do continuous maintenance. So the obvious thing is software updates and upgrades. A lot of software is getting new versions from time to time, so you have to make sure that up-to-date versions are installed. You are also responsible for different kinds of usage analysis and supportive tasks. So if you are the only person who is using a computer, you know what's happening. You know what is too slow, what is working fine, what needs to be fixed. If there is a number of people who are using the system, it's much harder to figure out what exactly you should be doing. So making sure that you are communicating with your users and you know what they are doing is very important. There is obviously issues with problem solving. So whenever something stops working, either hardware or software, you have to figure out what was the problem and you have to solve it. A very important thing is safety and security. So backup is pretty obvious one, but also intrusion detection and different things related to security. If you are administrator of a system that's being used by multiple people, then in almost all cases, there is some kind of network access to this system. So you have to be continuously monitoring who is accessing the system, in what way, and if there is some kind of unauthorized access, you have to be able to react as quickly as possible. And of course, different kinds of user support. Depending on who is your users, they may be pretty familiar with how computers work, or they may be pretty much clueless. So what kind of level of user support is very, very depending on the particular context. But in almost all cases, the system administrator has to be able to help users in solving their problems. And the first step is installation. We are talking about GNU Linux systems in this course, so the first decision to be made is about the distribution. You can choose basically whichever distribution you prefer. There are differences between them depending on what your goal is. Some of them might be easier to set up than others, but in general, it doesn't particularly matter all that much because almost any distribution can be adapted to whatever needs you have. It's just a matter of how easy that will be. If you start with something that's closer to what you are looking for, it's obviously going to require less work. Once you figure out what distribution you need, you choose the installation medium. You can do it CD, DVD, USB memory, but you can also set up a network server which will allow you to make installations on a multiple workstations from a single server over the network without having to do all those things by hand. You can also configure it in such a way that you will be able to pre-specify all the details and then you don't need to do anything during the installation. It will be completely automated, which will potentially save you a lot of time if you have a lot of computers on which you want to make this kind of installation. Next, almost all distributions come with different flavors. So the most obvious one, for example, for Ubuntu, they are called desktop and server. And the desktop one is something that you could install if you are looking for, well, a desktop computer. So that one obviously has graphical user interface in the form of X Windows. It comes with the user level applications such as OpenOffice, GIMP, Evolution, and a lot of similar ones. On the other hand, server, as the name suggests, comes with Apache for serving web pages, MySQL or Postgres as a database engines, PHP for dynamic contents, Bind for DNS server, and so on. So depending on which of those two flavors is closer to what you are interested in, it's easier if you start with the appropriate one. But it's of course possible to install all of those tools on both of those. So it depends. Regardless of what you choose, you will always be able to configure it according to your needs. And similarly for both of those choices, you can install a lot of additional packages. So you can add programming tools or administrative tools or whatever other applications you are interested in. The one important aspect of installation is also what to do with the hard drive. So you typically want to do some kind of partitioning. You want to have some bootable partition, maybe, especially if you are thinking about having Linux as a desktop computer, you might be interested in having Windows partition as well. And even for Linux machines only, it also in a lot of cases makes sense to partition the drive in different ways. So you need definitely at least one partition for the main root directory, but then it's also perfectly possible to put a lot of different directories in the hierarchy on their own partitions, and there are valid reasons for doing it. You can also put a number of those on the network shares, so on different machines on the network. Again, there are reasons for doing it. And you typically want to have a separate partition for the swap drive. If you think how Windows does it, Windows just uses as a single file as the swap memory. But for Linux, it's possible also to use a single file, but you get significantly better performance if you designate a special partition for the swap. Now, if you choose your hard drive sizing correctly, so after some time you figure out that, well, you actually need more space than you had, it's possible to resize X3 partition, but it's not recommended and typically not something that you would really need to do. In a lot of cases, it's much easier to just move some of the data to another partition. Because again, from user's perspective, if you want to add another partition in an operating system like Windows, you will end up with a new drive, so you cannot really hide this fact from the user. But in Linux, everything is rooted in a single directory anyway, so for user, it doesn't make any difference if, for example, /home and /usr are on the same partition or not. So if you want to move data from one partition to the other, or if you want to create a new partition, here is the list of commands that would more or less allow you to do that. So we have not discussed a lot of them. Well, CP we have and the RAM we have, but mount, for example, we haven't really talked about because it's not something that's very common. But now would be a good time to figure out what happens in each of those steps. And as I said, the big benefit of doing something like this is that it will be transparent for both users and applications. So after the fact, everything will still be working the same way. If you think about what happens when the computer boots up, so first BIOS performs a system check and then initiates something called bootloader, which starts the loading of operating system. And the first really popular bootloader for Linux was called Lilo, Linux bootloader, and it allowed you to select the operating system from the menu, and it was configured in a particular file that later needed to be compiled in order to work. Now, Lilo is a little bit obsolete, so Ubuntu comes with a bootloader called Grub, and this one is significantly more advanced. So if you think about how it works from BIOS's perspective, BIOS just loads the first 512 bytes from master boot record of the hard drive, but group is much more complicated than that. It wouldn't fit in that much memory. So this is just group stage 1, which in turn loads group stage 2, which is, as I said, significantly bigger. And group allows you to choose which operating system you want to run using a bash-like command line interface. So it's not as powerful as bash, it doesn't run actual bash, but it's very similar for simple things. But contrary to Lilo, it actually allows you to modify the settings, for example, to dynamically decide parameters you want to pass to the kernel and so on. And also, both group and Lilo can load alternative booting programs. So you can easily boot, for example, Microsoft Windows from group. Once bootloader is ready, it loads and executes a process called init. So this is the first thing that happens actually on the Linux side, is process called init is created. So this one will always has process ID of 1, because that's the first one, and it's going to be an ancestor for all the other processes. So all the other processes are created by init or by processes created by init. So you can see it using ps command. And this is the actual beginning of Linux boot sequence. So init does a number of important things. So it initializes hardware as well as hardware drivers. It sets up the default path. It creates swap memory. It does some file system checks to basically make sure that other programs can safely be started. So then it starts various system services, things that are necessary for everything else to work. It creates some text terminals and virtual consoles, so it allows you to log in, for example. It sets up graphical user interface, and it executes some initial scripts that users can create to, well, root, not any user, but root can create to adapt a particular installation to individual needs. Almost all Unix-based systems, so not just Linux, have the concept of run levels, which are basically different modes of operation of the system, and also can be useful for proper sequencing of services. So you typically start at the run level 0, which is shutdown, so computer is not running here. You go through run level 1, which is single user. You can stop at run level 1, then you will just have single shell prompt with root access. There will be no networking, no graphical user interface, no multi-user capabilities. And this is basically intended as a rescue or maintenance mode. So sometimes you will be using it actually if you have tried the commands from before for resizing partitions. Linux single is basically what puts you here. Then you have second run level, the default one, at least for Ubuntu. The definitions of run levels vary significantly between different distributions, but for Ubuntu, the run level 2 is the default one. A lot of distributions have run level 2 as the text only, and then run level 3 or even farther as the graphical user interface. But the general idea is that by going from 0 to some higher levels, you turn on different capabilities step by step so that you can ensure that at each step you already have some baseline on which you can build. So you, for example, don't start a graphical user interface before you start networking or similar things. And then run levels 3 and 4 are not really used in Ubuntu. And then run level 6 is the reboot. So when you reach 6, you basically go back down to 0 or 1. And the main reason for run levels is actually for the shutdown. So during normal operation of the system, the data in a lot of places is not kept in consistent stage. So there is a lot of caching going on, and also some applications are designed in such a way that they don't save the data on disk all the time. So it's important to let the system shut down gracefully so that all the data can be committed to the disk as well as the hardware can be deinitialized. Now, it's not always possible in case of power failure or so-called kernel panic. When there is a problem within the kernel, system will just shut down because there is nothing that can be done about it. But those kinds of cases should be minimized. So it's important that when you want to shut down the system, you go either to run level 0 or run level 6, and there are commands reboot, shutdown, halt, and so on, which can do this. In Unix operating systems, if you think about hardware, most of it is actually represented as different kinds of device files. So they are typically located in dev hierarchy, and they are not actual files. There is no, on the hard drive, there is no place where those kind of files would be located. They are just virtual entities that can be used to simplify access. And nowadays, it's less common to be accessing the dev hierarchy in different ways, but it used to be much more important. Now, a lot of the manual interactions with the devices is done automatically. But it's still important to be aware of things that happen there. You can also list various devices that are available using lshw command or lspci for listing PCI devices. Both those commands provide a lot of information, and it can be very helpful in trying to figure out what's the problem if something doesn't work the way you expect it to work. If you think about graphical user interface, there is no such thing as normal or standard user interface in Linux. There is a system called X window, but it only contains low-level graphical operations, so this isn't really anything that the user sees. The consistent look and feel that you are expecting is done using something called GUI toolkit. So this one will contain things like buttons, edit boxes, tabs, different menus, and so on. And there is a lot of different GUI toolkits. For Windows, there is MFC. For Linux and similar systems, there is a lot that you can choose from. And on top of those, you build something called Window Manager, which basically mediates between client and server of X. So it contains things like window decorations and management, frame, title bar, transparency, how to minimize windows, what happens when you drag or resize windows, and so on. It also typically contains things like the start menu, virtual desktops, similar functionality. And there is a lot of different window managers that you can choose from. Here is a short list of some of the simpler ones. There is a freedesktop.org organization or project which aims to increase interoperability of different desktop environment. So the idea is to make it easier to combine things which have been designed for different window managers, and that includes some functionality like drag and drop, recycle bin, clipboard, and similar things. It consists of system libraries and APIs, as well as human interface guidelines. So how should a user interface be designed in order to be useful and easy to use for humans? And two of the most famous project or window managers that came out of this project are KDE and GNOME, but there are some others as well. In Ubuntu, the default one is Unity, which was originally based on GNOME, although by now most of the code has been rewritten. And this has several new and pretty interesting ideas that you have probably already seen. I have talked about the root user account before. As a reminder, it's a special account used for system administration, and the idea is that this account can bypass all the regular system of access permissions. So any permissions that are enforced for other users, they don't apply to root. And the idea is, of course, that there is some number of operations that has to be done from time to time and under special circumstances. It's not something that you would want regular users to be able to do, but from time to time it's necessary to do things like, for example, editing global configuration files. So once you set up a system appropriately, it should be working fine, but from time to time it will be necessary to make some changes. And you don't want regular users to be able to make those changes. You only need you need this to only be accessible to system administrator. And on a slightly lower level, there is a number of very specific operations that are also only available to the root. So for example, changing file ownership is only available to the root. And the main reason why regular users are never allowed to change file ownership is the set user ID permissions, of which I have talked about before. I will talk about them a little bit in a moment again. Similarly, killing processes that belong to other users. You obviously are allowed to kill your own processes, but you are equally obviously, as a regular user, not allowed to kill processes belonging to others. Now, there has to be a mechanism within the operating system to do this kind of thing. Otherwise, single user could just create a lot of processes and cause the whole system to stop working properly. So there has to be some mechanism for dealing with it. One a little bit historical, I would say, thing is, in order to bind network ports below 1024, you need to be root. The original idea was that those kind of low number ports are supposed to be used by important well-known services, for example web server, and so you would want remote users to have some trust when connecting to those ports. Now, in modern internet it doesn't really work because you can never trust an external machine, and besides, this kind of scheme is only available in Unix-based systems. There is no such restriction on, for example, Windows. But initially that was a pretty interesting idea. Also, any kind of direct access to hardware is something that only root can do, because direct access, for example, to the hard drive, if you can specify that you want to read data from a particular plate, cylinder, and sector, obviously the operating system has no way of knowing if you, as the regular user, would have permissions to access this kind of data. So those kinds of operations can only be done by root. And similarly, this kind of account should never be used for regular work. It's just too easy to break things. In Unix-based systems, regular accounts are working perfectly fine. Like in Windows, it's really hard to do anything useful if you don't have administrator permissions, but that's definitely not the case in Linux world. So very rarely you have to do things using root account, and even if you do, you typically just want to execute one or two commands. Now, for the actual operating system, the name root doesn't have any particular meaning. You can rename the user to something else and it will still work. What matters is the user ID being equal 0. So that's the important part. And often for safety reasons, root has a special prompt. So regular users have prompt ending with $, and root has prompt ending with the hash character. As I said on previous lecture, you can change it. You can change it to whatever you want, but this is a convention which is pretty common. Now, initially, what happens is when the system boots, the init process is run with their own privileges, because obviously a lot of low-level work needs to be done. So this process has to have root privileges. It has to be able to access hardware and so on. And the actual permissions will only be added later. So the general idea of how computers work is that the first process that starts has full access to the machine. and it's only afterwards that limitations and restrictions are added by the operating system. As far as process permissions go, it's only root processes that are allowed to change their effective user ID. It's called dropping root privileges, so you have to have root privileges in order to be able to change your current user, which means you can only go down. You can only lower the privileges that you already have, which obviously makes a lot of sense from security perspective. And this is actually something that happens pretty often. A lot of servers will only need root privileges at the start when they will, for example, access the configuration files or set up the network operations. And after that, they are perfectly fine working as regular users. Similarly, the dropping of root privileges is also done by the login process. So after a particular user is authenticated, the login process needs to change from root privileges to whatever user has just logged in. Now, to go the other way around, to acquire root privileges is only possible by starting a new process. So there is no way for an existing process to just increase its privileges. You have to actually start a new process. This is not particularly restricting because you can always start the process running whatever program you want. But again, it's pretty important from security point of view. You already know how to access root. Again, just as a reminder, root is a locked account, so you are not supposed to be able to log into it, neither from the console nor from the network. Now, when I talked about the booting of system about recovery mode or single mode, which is the simplest way to get root privileges. And getting this is pretty trivial if you have physical access to the machine. So if you have access to, for example, group loader, it's really easy to just put the operating system in recovery mode and get full access to it. Which is why high security systems is also important to make sure that physical access to the machine is limited. Now, the most common way to get root privileges is to run a program with so-called set user ID permission. An example of that one is passwd for changing your own password. And there are su and sudo commands that you have already worked with. Now, if you think about how user bean password program operates and why does it need the set user ID permissions, you obviously need this program to be able to modify the etc password file or etc shadow file at least, depending on how the system is configured. And this file can only be modified by the root. And you can't just give every user permissions to modify this file because that would be very dangerous. You could just change passwords of other people. That would be really bad. So there has to be some way for a utility like this to temporarily elevate the privileges to do some particular well-defined task. So what setUserID does, it uses permissions of file owner, not the current user. Most of the time, when you as a regular user start the process will be run with your permissions. The process will only be able to do whatever you are allowed to do. But it works differently for files with setUserID permission set. Now, this kind of functionality is actually necessary for a usable system. Every single operating system has some similar mechanism. Now, the problem with setUserID programs is that they have to be very carefully designed and implemented, because any kind of bug in the program is a very serious security vulnerability. Those programs need to perform a simple, well-defined task like passwd. It's just supposed to change one small piece in one particular file. And it's also important that they do proper authorization. So they figure out if you are actually allowed to do whatever you are asking. So if you try to change your password using passwd, it will first ask you for your password just to make sure that you really have, you are really supposed to be able to change password for this particular user. You have already used sudo command on the labs, so I will not go into details. You know that sudo asks for current user's password, not for the root password. So the idea is that you as system administrator, first of all, you can use sudo to do different things, but also you can give partial permissions to other users to do some of the administration tasks, but not all of them. And you configure it using the sudoers file, which I have again shown you before. But last time we looked at it from the perspective of the user, so when you wanted to do something. Now, if you think about how you can use sudoers file as a system administrator in order to allow some users do some of the tasks, if you think about the operating system or a machine which is used by a lot of different users, and you want some of them to kind of help you in administering it, when there are some simpler things that you want to be able to do. It's, for example, in here there is a pretty common pattern where you have some users who are, let's call them operators, and the operators are able to use some of the commands, but not all of them. So for example, they are able to shut down the system, maybe if the power is going down and you have backup power for say half an hour, it's enough to shut down the system gracefully, not enough to keep it running. And then they might have some number of commands to which they have access, basically for ensuring proper operation, but they don't necessarily need access to, for example, adding users or changing configuration files or so on. So this kind of setup allows you to be really flexible in who gets access and permissions to do what on a system. Backups are probably the most important task, in practice at least, that you will be doing as the administrator of the system. It really hurts to lose your own data, but if you lose somebody else's data, that's a completely different thing. And it's very important that you take into account different ways that you can lose data. So there are things like hardware failure, software bug, human error. All those things can cause you to lose data. And it's important to know that there are different ways to prevent each of those. So you have to figure out what you are mostly worried about and design your backup scheme in such a way that you are protected against all of those things to appropriate degree. Now, especially in the course, whenever you are modifying some kind of configuration file, always make a copy of it. This is going to be very useful, because you will often, or at least from time to time, you will change something and things will stop working. So it's really important to be able to go back to a setup that was correct. Now, if you are just administering your own personal computer, it's not such a big deal. But if you are in charge of a large system, then you need to have some kind of backup plan. And a backup plan which specifies more than just, well, let's copy some data to a removable drive and that's going to be enough. Like, the backup plan needs to specify when backups should be done, who should do it, how to do it, how long the data should be kept, and so on. There's a lot of different issues to think about, and it's very important to do realistic estimation of risks and the costs that are involved here, because the more extensive the backup, the more will it cost, and it's not necessarily worth doing a lot of very complicated things if the chance of problems happening isn't significantly big, or if the cost of losing the data isn't significantly big. So it's really important to have a realistic estimation of what you are really targeting. And it's also very important, something that a lot of people are forgetting, that backup also has both security and privacy issues, especially if you are working with sensitive data. It's really crucial to remember that whatever backup you have, it has to be protected to the same degree as the regular data. There are a lot of cases where accessing backups of really well secured systems has been almost trivial. So this is very important to think about. If you are only doing backup occasionally, then it's probably best to copy all the data and not really worry about very complicated schemes. But if you are doing it regularly, maybe every day or so, then you don't really want to have so many copies of the same data. So then what you want to do is some kind of incremental backup, where you only make copies of files that have recently changed. So you can use find to do this. There are of course a lot of tools that will do this kind of backup for you. And you can also do something called differential backup, when you only store the difference since last backup. Now the idea being that most modifications are minor. You are not changing the whole contents of the file, you are just changing some part of it. So it doesn't make sense to store the data that you already have for the second time. So there are a number of different backup methods that you could be using, and it's important to figure out what is the best for your particular case. One tool which is useful, for example, for doing backup, but obviously not only, is something called cron. And what cron allows you to do is execute commands at predefined times. So there is a configuration file etc cron tab, in which you specify which commands should be run at what times. And those will be run in a cyclic manner. So you specify, for example, on first, third, and fifth weekday, on every hour at minute 59, you want to run this particular command. As a system administrator, you also have to monitor system resources. So you have to find out about problems, preferably before users start to complain. So you can use top free vmstat utilities. So here is an example output of top utility. You can also use the logs that are available in the /var/log directory. Most interesting events in GNU Linux system will be logged there. And most modern systems use some kind of centralized logging server, for example, rsyslog daemon in Ubuntu. And the nice thing about this kind of setup is that it allows you as a user to specify how do you want to split those messages depending on a number of criteria. So a good starting point is usually the dmessage command, which displays information from var log messages, which are different kinds of global system messages. So they are mostly useful for looking at startup information. So if something doesn't work when you restart the computer, some devices are not properly initialized or so, this is the place to start looking. But you can also find log files for other, for example, for particular daemons. So there will be a log file specifically for, I don't know, Apache web server. But you can also put different messages in different files depending on the on types of events that they are related to. Here is an example of some number of typical log files that you can find interesting. We have already talked about process management. You know what the ps and kill commands are, but from system administrator point of view, there are some other things that you can be doing. So there is a command called nice, which can make a particular utility behave nicer. So basically, just by lowering its scheduling priority. And as a root user, you can also increase some utilities scheduling priority. You can use time command to measure how much time or how much resources a particular utility is using. There is uptime command for figuring out how long system has been running. You can get information about free disk space and disk space used by a particular directory or file. I have mentioned daemons or servers before, and we will be definitely talking more about them on future lectures, but it's important to have an idea of what's the difference between daemon and a utility. So, first of all, daemon is some program running in the background. You typically have init process as a parent, because in Linux, when a parent is killed, it also kills all the children. So you want to make sure that the daemon doesn't stop working when, for example, the user login session, where the user logouts from the user login session. The daemon is not associated with any terminal, so it doesn't have standard input or standard output. You typically have root as the working directory. It uses various kinds of logging mechanism for communication. As I said, no standard input, standard output, typically no graphical user interface windows, so it's really difficult to communicate with the user using anything other than the logs. You typically have servers execute set user ID at some point, so changing from root to some lower level permissions. And often you only have one copy running. So you want, for example, if you have web server, you only have one web server to be running. There are situations in which you might want to have more than that, but it's not that common. And you typically want daemons to be active even when no user is logged into the system. So this is one of the important things. You can think of them as servers, so web server, SSH server, email server. Those kinds of things definitely should work all the time, regardless of if somebody is logged in or not. And there are also some system tools that should be running, like cron or syslog itself. You typically have those kind of daemons or services come with some kind of initialization script, because starting them is not always entirely trivial. You want to specify different kind of configuration files and so on. And what you typically do is you put those configuration file, the initialization scripts, in etc initd directory, and then those scripts can be used to both start and stop the service. You can do it by hand, but since they are using common syntax, you can also specify that they should be started and or stopped in a particular run level. And this will be done automatically. So you can say that, for example, you want Apache to be started every time you start the system. And Ubuntu uses, as a replacement for initd scripts, a service called upstart. And during startup and shutdown, the upstart operates very similarly to init daemon, so there isn't that much difference here, but it can also be used for starting and stopping tasks based on specific events. So you can say that when you connect or disconnect some hardware, you want to start and stop particular service, or when you change network connection. And it also allows respawning services. So when, for example, web server crashes, upstart is capable of automatically starting it again. There is a number of servers about which we will be talking about in the future lectures. So we will be talking about DHCP, web server, firewall, DNS server, email server, and file server. Another important concept when talking about servers is the change root, which allows replacing the true root directory for current process and all its children with something else. And this is mostly used for privilege separation. So in order to improve system security, you want to limit the parts of the file system to which a particular server has access to. You can also use it for other things like software testing, but it's definitely most commonly used in order to limit permissions of individual daemons. As a system administrator, you need to know how to communicate with your users. There are a couple of things built into Linux. etc message of the day is important one. Write utility can be useful. And of course, email, web, phone, those are all things that you may be using at different points. We have talked about package manager before, but again, mostly from the user perspective, so when you wanted to install something. Now, if you think about how package manager is useful from administrator's point of view, it's especially useful when you are installing software for other people. So for example, because package manager maintains a list of installed packages, it's very helpful when you're upgrading or migrating, because you may not necessarily remember what kind of software all your users are using. So it's important to find out what is installed on a current machine if you are, for example, trying to upgrade to a newer one or something like this. You can also find new packages in a repository, and you can be, to some degree, certain that it has been at least a little bit tested, which again is very useful if you have a user who comes to you and says that he needs this particular software and you have no idea what it does. If you can find it in the repository of your distribution, you can be reasonably certain that it is pretty safe. It automatically handles updates of software, again, very useful for packages that you are not using. If you are using a particular application and there is a new important update, you will probably know about it. But if you are not using it, then having updates handled automatically is very useful. It also verifies dependencies among software packages, so takes into account what is already installed and only installs what is missing. Again, if you know what you have installed, it's something that you could be doing on your own, but maybe you are sharing responsibility for a machine with somebody else and you don't know exactly what has been installed on this particular computer. And finally, application removal, even in simple setups, is not necessarily trivial, but you can imagine what happens if you install some application, then you install something else, maybe with similar dependencies, and then you want to remove the first application, but you probably don't know which components are required by the second application. The idea is that package manager should be able to handle those kinds of things transparently. So you should know how apt-get operates by now. apt-cache and sources list. Now again, sources list is something which is more important from administration point of view, because you want to know where you are getting your packages from. And if you are doing it for your own, then probably the default repositories for distributions are going to be good enough. But if you are administrator for a bigger system, then it's likely that you will need to find some specialized software for whatever the company is working with. And then you may need to edit this and add whatever other repositories you need. It's also possible that there will be some software that you need to install for which there is no ready-made packages. You will actually need to compile it by hand. So it's not difficult. Ubuntu Desktop, for example, includes compilation tools by default, and if not, you can just install a number of packages and it will be really easy. So you can do compilation using the configure script and then make install. But typically it's really important to figure out what exactly you are installing. And actually one of the things that you might want to install from the source is actually the kernel. So the kernel is the heart of the operating system, and you typically upgrade it together with the whole distribution. So from time to time, new versions of distributions come out and they will have up-to-date kernel. But there are cases where you need to make changes to the kernel sooner than that. Maybe there is some really nice feature that you really want, or maybe you just want to add or modify some functionality of the kernel. Now, Linux kernel uses dynamic modules, so most devices can be installed without modifying the kernel itself. But in some cases, if you need to tweak some low-level configuration details, it may require recompilation of kernel. And also it's important to know that you can have multiple kernels coexist on one system. You cannot, of course, run multiple kernels at the same time, but you can have one system on which you can run different kernels at different times depending on your needs. Now, if you want to update kernel from source, you start by downloading the source and then maybe also apply some patches. So for example, if you have some device which is not by default supported by the official kernel, somebody might have created a modification that allows you to support this particular device. So those kind of modifications are typically called patches, and then you can apply it and then build your own kernel. So the first step is typically to modify kernel configuration. So there is a tool called menu config for that. After you do this, you compile the kernel, then you install the kernel and the modules. You can use this kind of command, and this one will also change the group configuration for you. You want to create the initial RAM disk and then restart the system. And if everything goes right, you will have a new option in your group menu, and it will allow you to start with the new kernel. And as I said, the nice thing is that you will also have the old kernel available from the group menu. So if your new kernel for some reason doesn't work, you can always boot back to the previous one, and there shouldn't be any problems with that. So the interesting step here is the menu config, because this is the place where you change the configuration of the kernel. So for example, you choose which kind of hardware drivers do you want. You obviously want drivers for the hardware you have installed, and maybe you don't need other drivers. The kernel that comes pre-compiled with a distribution is a very general one. The idea is it's built in such a way as to support as wide specification of hardware as possible. If you know what is your hardware, maybe you don't need all the other drivers for other devices and so on. But you specify, for example, the CPU, you decide which external devices you want to have enabled in the kernel. You specify networking options, different kind of power management things, and so on. You specify which file systems should be supported by the kernel. You decide if you want to have loadable module support or not. You can just build a static kernel which contains everything that you need and disable the loadable module support altogether if you don't need it. And then there is a number of settings and features that you can modify. So you can have different kinds of inter-process communication enabled. You can have different levels of process and user accounting. There is a number of optimizations that you can enable or disable depending on your particular needs. And if you do this, or maybe even if you're just considering doing this, you can try to see what kind of modules you have, for example, currently loaded in your kernel. So you can use lsmod for that. You can get information about other modules that are available. So mod info will display you some configuration parameters, version of the module, and so on. And you can use mod probe to add or remove loadable kernel modules. And the final thing I wanted to mention today is Wine, which is a tool which allows you to execute Microsoft Windows binaries in a GNU Linux system. So the way it works, it makes Windows API available to a particular application, so it's compatible on the binary code level. All the system cores are implemented using dynamic link libraries. And the functions that are offered by Windows kernel are just re-implemented using Linux system call. So you will be using fork exec pair instead of create process x, for example. Now, it does not really cover 100% of functionality, so it's not guaranteed to work with all the applications, but a large number of applications will work just fine. So Wine works completely within user space, it's not part of Linux kernel. It actually uses some of the native DLL libraries and some that are specially prepared for Linux. And you can play with configuration of Wine. You can define different orders of loading libraries, different versions of DLLs, and so on. You can also do it for particular application. So some applications will work better with native DLLs, and others will work better with Wine replacements. But if you really have some kind of application that you want to be some kind of Windows application that you want to be running under Linux, Wine might help you there. So, thank you for today, and I will see you on the lecture.